In this video, let's look at Microsoft Florence-2. This is a vision foundational model. This model can do various vision tasks like segmentation, semantic segmentation. It can do region proposal, it can do image classification, it can do detailed caption generation, it can do visual grounding and object detection, it can do phrase segmentation. Now if you look at these tasks, they can be organized as in the increasing order of spatial hierarchy and increasing order of semantic granularity. So this is one generalistic vision foundation model which can perform all these tasks. So in the spatial hierarchy, you can go at an image level, region level to pixel level. So you can go from a pixel level to an image level. Okay. And similarly in semantic granularity, you can go at a none to fine-grained semantic granularity. Okay. So you have these tasks like detailed caption and visual grounding and object detection at fine-grained semantic level. At a coarse semantic level, you could have caption generation. And at a semantic level, it is like in no semantic level, it's about classification. Okay, so this is a vision foundational model. So how did they create this model? What is the architecture of this model? Let's go to the architecture of this model. Before that, what I want to say is that this model has been released on Hugging Face. It also has an MIT license. Now, what is special about this model is that this model is just having 770 million parameters and it is able to perform say equivalent to or it beats a 80 billion parameter model like Flamingo. Okay, so that is the thing over here. It is just a 770 million parameter model which can beat bigger 80 billion parameter models. Okay, so let's get into the architecture over here. If you look at the architecture over here, let me minimize a little bit. So the idea over here is that you have your image as an input which you pass through an image encoder and get your visual embeddings. You also have multitask prompts. Okay, these prompts can have locations as well. Location over here means a bounding box or it could be a polygonal mask. Okay, so it could be multitask prompts. Now this image plus basically this text prompt plus locations in the text are converted into text plus location embeddings. The visual embeddings and text plus location embeddings are concatenated and given to a multi-model transformer encoder decoder architecture. Okay, this gives your output as text plus location tokens. Now this text would plus location tokens will change based on the various tasks. Okay, so that is the idea over here. So this model consists of an image encoder and a standard multi-modality encoder decoder. So they train Florence-2 on FLD 5 billion data, resulting in a uniformed multitask learning paradigm. Okay, resulting in a generalist vision foundation model which can perform various vision tasks. So if you go to Hugging Face page over here, they have a sample inference notebook. Okay, so if you quickly look through the inference notebook, you can get an idea of what kind of tasks are can be performed by this model. So given an input image like this, okay, you can get a caption for this image. So the caption is a green car parked in front of a yellow building and the prompt over here is caption. So you can have a detailed caption as a task prompt and you can get a detailed caption over here. The image shows a blue Volkswagen Beetle parked in front of a yellow building. Okay, so this is a detailed caption. You can get a more detailed caption also. So this is the caption generation tasks. Now with the same image as input, with changing the prompt as OD, you can get object detection. So here it gives the bounding boxes of the objects which are present with labels like car, door, wheel. Okay, wheel. So basically the front wheel and the back wheel, right? It gives that as an output. So it can do object detection, right? And you can display the object, basically the bounding boxes. It can also do dense region caption. So here input format is like in the prompt you can give dense region caption. So basically this one, and you can also give some bounding boxes and labels. This is the output. Okay, but in the prompt you will give us dense region caption. So if you give that as a this thing, results of that, you will get like this. Okay, so here you get more detailed of the objects like door, wooden door with metal handles. Okay, turquoise Volkswagen Beetle. So this is quite interesting. You can also do region proposal over here. So the region proposal output is again bounding boxes and the labels are not present, but it gives the regions which are present in the image. You can do phrase grounding. Basically you can do caption to phrase grounding, and then it gives the regions plus yellow building, a green car, so on. You can do semantic segmentation as well. That is what is shown over here. You can get the masks of that region, right? You can do region to segmentation. You can specify bounding boxes over here in the text input. The task prompt is region to segmentation. You can specify a region and it can segment that region and give it to you. Okay. Then you can do open vocabulary detection, which can detect both objects and OCR text. Okay, so it can do OCR as well. So here you can say green car and you can do open vocabulary detection. So it says a green car over here. It detects that region. Okay, you can give an OCR related task. You can pass an image and you can ask it to do OCR, which is what I tried in the demo space over here. So I gave this input image and the task was OCR, and like I asked optional textbook what are ingredients or something. So here it does OCR and gives the complete OCR over here. I'm quite impressed with the accuracy. There were some enough examples over here on OCR accuracy in this particular paper. So yeah, see, this is handwritten text and it was able to do OCR on it. It is able to even describe that image. Here they have also done comparisons with various other models like GPT-4 Vision. And if I look at the descriptions of these descriptions of Florence-2 versus GPT-4v, GPT-4v is a little bit more detailed when compared to Florence-2, but Florence-2 also produces very usable descriptions. Okay. For example, this particular image, right, of a Fuji apple over here. This image is a close-up of a red apple with a green label. The label on the text is Fuji. So it is basically done OCR on this label, right? Indicating that the apple is from United States. The apple appears to be fresh and has a shiny texture. The background is white, making the apple stand out. GPT-4 also gives the same this thing. It indicates that it is organic because the sticker says somewhere organic over here. It is able to do that, and it gives some more details over here. And other models are Lava or Mini GPT-4, which has been compared over here. So when compared with say GPT-4, Florence-2 gives very usable descriptions. GPT-4v gives slightly more detailed descriptions. That is what I see over here in the results which has been put over here. Okay. So you can also go and try out Florence-2. Now just a little bit about the, so here are some OCR examples, right? So here it is done very good OCR over here. OCR with region, OCR examples. Okay, so you can use it as also for OCR based tasks. All the other examples are present over here. I just want to talk about a little bit about the database. The data set basically. So let's go to the beginning of the paper again. So this particular FLD 5 billion data set which they have developed consists of 5.4 billion comprehensive visual annotations on 126 million images. Okay, so they created these annotations for all kinds of tasks over here on close to 126 million images. Let me check it again just to be sure. Yeah, it is 126 million images. So this model is a huge development in as a foundational vision model. So you can try it across various tasks. Okay, I'm not sure if this data set also will be released. Okay, let me go to the conclusion to see if they are talking about this data, or maybe in the abstract to see whether this data set they are releasing or the model is released, but I'm not sure of the data set. Let's see over here. Okay, I think the model is released. I'm not sure of the data set, whether the data set will be released for others to be for others to make use of, right? Whether if they want to train unified vision foundation models. Okay, this is the data set, a more detailed example. Let's see if, okay, this is the architecture. Let's go to the conclusion. Okay, they talk about Florence-2. They talk about how this data set was created. They constructed this data set. Yeah, but I don't think they mention about release of data set or anything. But this model is released. There are two variants of this model, large and base. Okay, and this is the size of the model. The base is close to 230 billion parameters and the large is 770 million parameters. This is 230 million parameters. Yeah, so you can go and try out this inference notebook. You can also try out their demo space. This seems to be a very interesting development and a very useful model which has been released from Microsoft. I hope this video is useful to you. If you like the video, please like, share, subscribe to the channel. See you in another video.